Compose these two functions, and basically all forms that you can do. So f composed g, g composed f, and then f composed f, and g composed g. And then asking the respective domains for all those. So the first thing maybe to think about before we start doing anything is that the domain of f is going to be all real numbers. Okay, and the domain of g is also going to be all real numbers. Okay, you could take the cube root of negative numbers, so there's no issue there. So that's something to keep in mind as we go through. Let's write this down. Domain. Let's see here. Domain. All real numbers for that. Domain. All real numbers for that. But when it asks for f composed of g, remember that means f of g of x. Okay, so I'm going to rewrite that then as f of g of x is now the cube root of x. Now I'm going to plug that function into f where I see x. So it's going to become cube root of x. That's what I'm plugging into that term right there. It needs to be cubed and then plus 9. Okay, so now the cube root and the power of 3 should cancel out, and it leaves me just x plus 9. Okay, so at this point, once I find the function that they're interested in, I've got to go back and think about how we determine the domain. And the first thing is to look at the input function. The input function in this case is g of x, and you have to incorporate domain issues that g of x may create. Well, we go to g of x, and we said its domain was all real numbers, right? There's nothing there that we needed to kick out. So that's good. We don't have to do anything there. The next thing that you do then is you look at the final composite and think about, is there any division or square roots or even roots, I guess, in x plus 9? And there's not, so there's no domain issues here. So again, our domain for the composite function then is still negative infinity to positive infinity because nothing should have been kicked out. Does that kind of make sense? And if you graph those, you will see the complete line x plus 9. And we did one of these last week where there was it was an even root, so I think it was square root or something like that, and you saw that it cut the line's x values off at 0 and only graph to the right of the y-axis. So this one's going to graph the whole line from negative infinity to positive infinity. Reversing the rules, then we go like g composite f. Okay, remember that means g of f of x. F of x again is x cubed plus 9. Okay. Now I'm going to plug that into g. Okay. Well, when I plug that into g's function, it's going to be the cube root. Okay. Now x becomes x cubed plus 9. Okay. Now, people want to cancel the cube root and the x to the third, but you can't do that because this is a sum. Does that make sense? So you can't just cancel the things you want and be left with like x plus 9. It doesn't work that way. And if you just took like arbitrary values of x, you could see why that doesn't work. If I took, and this is always a good idea to do this. If you struggle with your algebra, remembering a particular rule, and I'm asking myself, is this allowable to cancel like that? Well, I'm going to take, just take a number like, I don't know, let's let x be 2, okay? If x is 2, this becomes 8 plus 9 on the inside, right? Okay, well, 8 plus 9 is 17, correct? Okay, so this should say cube root of 17. So we're typing in cube root of 17. And there's several ways you can do this on your calculator. I'm just going to raise it. I've changed my calculator mode. I don't like the math print form. All right, so 17 raised to the 1/3 power. That will take the cube root. Okay, so I get 2.571. Okay. Now the question is that equivalent? Is the cube root of 17 equivalent to the fact that if I put 8 right there, okay, I should get, so people are saying cancel those out. All right, so if I cancel those out, that would give me 2, right? Okay. And then I'm not sure what people would do here, whether they would keep the 2 underneath the radical, or I think most people probably bring it out, but then you have 9 left underneath, right? Cube root of 9. So to have 2 times 9 raised to the 1/3 power. I think that's what most people would do. Once you see cancellation underneath the radical, they usually bring that out. And then this 9 doesn't get canceled with anything, and then I hit enter, and I don't get the same value, right? So that tells me that this cancellation of just the cube root and the x cubed is not allowable. Okay, so just usually when you have an issue, remembering what the rule is, go ahead and plug something in for x and see if your simplified kind of evaluation process will help jog your memory of what you're supposed to do or what you're allowed to do. So this case, we look at this thing here again. That's the inside function, or the f of x, and there were no domain issues there. So there's no restrictions with that. And then I get to the final composite, and because this is a cube root, it doesn't matter what's underneath the radical. There's no domain issues there. So again, domain is all real numbers for that. Keep going through. They ask you to do g of g and f of f. So g of g is equal to g of x. Okay, so remember g of x was what the cube root. How did I do that? What was the g was cube root of x. All right. So now I'm going to plug that back into g. Okay, so that means that g, which was the cube root of x, that's where I substitute. Okay, but now I'm substituting that. So it's now the cube root of the cube root of x. Okay, which, if you want to do a little bit of algebra here, the cube root of x is the same thing as x to the 1/3, right? Is that going to make sense? Okay, so I could write it this way. Well, that means I got another cube root here. I could rewrite this as x to the 1/3 raised to the 1/3. And now what do I do with powers to powers? Careful. Multiply. So I get 1 to the 9th, so x to the 1/9, and that then gives me the 9th root of x. And that might be a little bit easier to recognize because it's an odd root. I don't need to worry about domain issues, right? I can take the 9th root of a negative number. Okay, so no domain issues there on the input function. No domain issues here on the final composition, and we should be good then. Say our domain again is negative infinity to positive infinity. In regards to domains, this one is because they're both no restrictions at the onset. It's really not that interesting of a question in regards to at least the domain part. Now if we do this one, f of x is x cubed and then plus 9. Okay, x cubed plus 9. So we go f of x cubed plus 9. Okay, now I'm going to plug x cubed plus 9 back into the f function. Okay, well that's going to be, the f function kind of has this format where I've got something there cubed plus 9, right? Well, that something there has got to be this x cubed plus 9. So x cubed plus 9. So I'm going to have x cubed plus 9 to the 3rd plus 9. Now my suggestion to you, just leave it that way. You could ultimately go through and expand that x cubed plus 9 times x cubed plus 9 times x cubed plus 9. and then add 9 to that, okay, for this final plus 9 at the end, but that expansion right now is kind of unnecessary. That domain, the input was all real numbers. Okay, so nothing got kicked out of there. This development here, there's nothing fraction-wise, there's nothing root-wise, so that's all real numbers as well. So our final domain for that F, composite F, is negative infinity to positive infinity. When we have, well, that worked great. There we go. All right, so F of X and G of X. Look at this. What can X not be here? Yeah, that's going to be an issue there. What about here? Is there anything that X can't be here? No, so the domain is all real numbers there, so I'm not going to write any restrictions. If I want to write F composite G of X, all right, so it's going to be F of 3x plus 12, okay? And now I go to F and I plug that in, so I'm going to go 3, okay, because this is the kind of the outer shell of what our final problem is going to look like, okay? So, and I say that term shell might be for those who maybe struggling with this, maybe an alternative way of thinking about this. If that's my outer function, right, my answer is going to have the same kind of setup that F of X had, okay? So it develops, like I said, a shell in regards to the 3 is going to be consistent, but now whatever the X was is going to be the G of X function, so it becomes 3x plus 12 there. And you can see at this format here, resembles this over here, doesn't it? Okay. So what we want to do then is look at the domain of this final function. Okay. And because we end up with division here, the bottom is not allowed to be what number? 0. So what number for X would provide the bottom to be 0? Negative 4. Okay. So in regards to our domains, the first thing we do is we look at any issues that thing might have created, the input value would have created. That function doesn't have a domain restriction, right? So nothing there, okay? But the second part then is to look at the final function, the final composition, and then we realize that X cannot be negative 4. So writing that in interval notation, then they're going to go up from negative infinity to negative 4, union negative 4 to infinity. And then that domain should change a little bit when we flip the functions. And that's the reason they're asking you to do these 3-4 different ways, because they want you to recognize that the domains are dependent on what the input is and dependent on what that final composition looks like, okay? It is not dependent on just that restriction and the restriction created over here if there is one. Does that make sense? I think that's kind of what it was when we did combinations. It's no longer that way. So I'm going to take G of F, which F looks like 3 over X. Okay. So now my shell of my problem is going to look at this G function. So I'm going to have a 3, something there, and then plus a 12, right? Okay. It might be a way some people like to do that, where they set up what the overall function is going to kind of look like without the substitution. Then we put in what we're substituting. We're substituting 3 over X. Let's put my 3 over X in there. We can simplify that. We get 9 over X plus 12. I am seeing people want to condense that into one fraction. Nothing wrong with that. It's going to be a practice that we need to do in the next couple chapters. But you can leave it as 9 over X plus 12 right now. It's no big deal. So in this case, again, we want to go back up to the input function, which was 3 over X. And what could X not be as an input value? 0. So that was the first restriction. X cannot be 0. And then I look at the final composition. And now here, what can X not be? 0. So redundancy, it's not a big issue. So then we go negative infinity up to 0. Union 0 to infinity. Just quickly kind of running through the next two. Let's do, like, the easy one would be G of X. So g of x is going to look like g of 3x plus 12, which that is then going to look like 3, 3x plus 12 plus 12. I'll let you expand that 9x plus 36 plus 12. Is there going to be any domain issues there? No, there's no issues with the input function. And then ultimately, there's no issues there. So negative infinity to positive infinity should be that domain. The order of the two would be f of x. So that's going to be f of 3 over x. Okay, and that's going to then become 3. Okay, 3 over x is the shell, so it's the final format. But that bottom function, that x, that input that I need to plug in, is now going to be 3 over x. Okay. Well, rewriting that, doesn't that become, multiplied by reciprocals, becomes that, doesn't it? Okay, because I've got 3 over 1 up top, multiplied by the reciprocal, the bottom fraction right here. So x over 3. 3's cancel. My mouse is, for some reason, being a little weird. The 3's cancel leaves me just x. Okay, so the final composition of these two functions is the linear function x. Okay, and there's no domain issues with that, right? But there is a domain issue here with the input. What's the domain issue with the input? Can't be 0. Okay, so we're going from negative infinity up to 0, union 0 up to infinity. And what's going to happen then is, that final graph, that final composition, if I take 3 over x composed with 3 over x, I get the line y equals x. And when you graph it, it's going to look like the complete line. But we need to know that there's a hole, basically. There's a point discontinuity at x being 0. At 0 is at the origin, basically. Yes?
Is there a reason you didn't distribute 3 into your cubes?
Just being lazy. Yeah, so you can go 9x plus 36 plus 12 if you want to, and add 36 and 12. Yeah. And I would think, because I don't know if they give you specific instructions on WebAssign to simplify. So they'd probably accept that, the way I've got there. What they probably won't accept is something like that what we got on the bottom, f of x. If I leave it as 3 divided by 3 over x, I doubt they would accept that because they want you to recognize that when because there is algebra there that helps us simplify it and maybe at some point kick a domain value out or something like that. So, but that top one, because it's just insured proper, I don't think they're going to have a big issue with that. Let's see here. Dave.